In example 5, we talk about how to use geometry to find shear and normal strains. Here we have a thin triangular plate, PQR. It is deformed so that the corner Q is moved to the right by distance L equals 0.12 inch, as shown here. A, B, C, L, its dimensions have been given. Then determine the shear strain at Q and normal strain along PQ. Okay, here we are not dealing with a square-shaped stress element, so you cannot use gamma equals delta over L to find the shear strain. Okay, we have to use the other one, right? Like a gamma equals alpha minus beta. I use angle before deformation minus angle after deformation to find the shear strain. Okay, let's see how can we solve the shear strain at point Q. Okay, let's change this thing to beta 1, and here beta 2. Here's beta. Okay, the overall thing is beta, the angle after deformation. Okay, the angle before deformation alpha is just pi over 2, right? So here to solve the first step, the shear strain at point Q, we just, as we mentioned, we just use this equation, the gamma Q equals alpha minus beta. And here alpha before deformation, the angle before deformation is pi over 2. And the angle after deformation beta equals what we have divided it into beta 1 and beta 2. So beta 1 plus beta 2. We just need to find beta 1 and beta 2, then add them together, get beta, and then you can calculate gamma Q by the first equation. Right. So here, this problem has been simplified to finding beta 1 and beta 2. Right. So first of all, let's look at beta 1. So we can find beta 1 from the first triangle here. Okay, the first triangle here. Right. So this is pi over 2 here. We just need to find what is the length here, and the other side, well, likely here, right? So what is the side here? Obviously, here is B plus L, right? And here it will be C. Right. So from this analysis in this smaller triangle, we know that tangent beta 1 equals B plus L over C. Right. So B is 6L 0.12 over C, that is 12. Here we have 0.4716 radian. Oh. This is not the calculated result, okay? We just from this equation, we can calculate that the beta 1 equals 0.4716 radian. Okay, then later you can try to find beta 2. Okay, in the second triangle, here, right? We just need to determine what is the side here and the other sides. Okay, this is still C, right? So what is the side here? This will be A minus L. right? So tangent beta 2 equals A minus L over C. All right, so A is 24 minus 0.12 over 12. So beta 2 can be calculated as 1.105 radian. Okay, now we can calculate beta. Right? The angle after deformation equals beta 1 plus beta 2. Right? Then the gamma Q can be calculated by pi over 2 minus 0.4716 plus 1.105. Right, so this will be negative 0.0059 radian. Again, what does this mean? What does the negative sign mean? Meaning that this angle beta is larger than pi over 2. Okay, so this is how we can use geometry to find a shear strain at a point. In the second step, we're finding out the normal strain along PQ. PQ is here. So after deformation to become PQ prime. Okay, so here the requested thing, normal strain will be calculated from PQ prime minus PQ over PQ. Right? So we just need to find the values of PQ and PQ prime. To find out PQ, we can just focus on this blue triangle here. The blue triangle here. Right? You have a B, and you have a C, right? So the PQ is simply B square plus C square root. Right? You get B is 6 square and C is 12. Then here the result will be 13.4164 inch. Then how about PQ prime? We have to find PQ prime from the red triangle here. Right, we know here is C and here is B plus L. Right, so this one can be solved from B plus L square plus C square root. Right, so here will be 6 plus 0.12 square plus 12 square. So you will get 13.4705 inch. Okay, now the epsilon can be calculated now. 13.4705 minus 13.4164 over 13.4164. So it would be 0.004167 strain, or 4,161 microstrain.